Hello and welcome to project presentation for IDL by Group 22. Our topic is deepfake audio detection using neural architectural search by applying reinforcement learning method PPO and DARTs. With increasing AI, synthetic speech generated by advanced AI is becoming increasingly indistinguishable from natural speech. Hence, deepfake detection becomes one of the most important tasks if something is coming to understand if something is coming from a genuine source or not. A lot of work has been done on deepfake detection, but all models require hyperparameter tuning. Neural architectural search with reinforcement learning is a novel approach which searches through a hypothesis space and finds the best neural architecture to be used for this specific task. We have built upon the paper by Geep and Patino, where they have used raw PC Dart and achieved an EER of 0.017 on an ASV spoof 2019 dataset. It's the best so far. We also implemented the research paper as the baseline implementation and were able to achieve around 0.028 EER by the same dataset that they on the same dataset that they have used. We then tried to build upon their paper by including the PPO approach with darts that balances exploration versus exploitation trade off on the same dataset that addresses all major attack types like text to speech, voice conversion, and replay attacks. For this project, we basically focused on TTS and VC dataset. In our approach, our dataset first goes through the feature extraction layer where we are able to extract the required features for that will be used to find the best architecture. It then goes to the search space where we have defined operations like convolutional blocks, skip connection, attention, etc. PPO first tries to explore more architecture through using the operations space and finds the best architecture that it can using the reinforcement learning methods. It then goes to the Dart where using gradient descent it tries to exploit the architecture that has been provided by PPO and find even more fine-tuned and better architectures. Then this architecture is trained on the complete data set to classify if something is a spoof or bona fide. We were able to to get new architectures from this hybrid approach. The architecture was divided into cell 1, cell 2, and cell 3. Cell 1 were normal cells that were focused on frequency aware operations and used more of convolutional sets. Set 2 used more of attention, and later cells were used for feature processing and final output. As a result metrics, we used uh, confusion metrics and ROC curve to understand how our model has performed. We were able to achieve over 90% of accuracy on the dataset. We then tried to compare our EER with the paper implementation, our baseline implementation, and how the hybrid model performed. We were The early results are really promising, where we were able to get an EER of 0.04 on validation and 0.15 on testing. We know that we didn't that this didn't match the paper implementation, but that was due to the restriction on the compute that we had. Our future work will involve more thorough testing and training of our model using the hybrid approach. We plan to modularize our code and build a comprehensive pipeline to generalize across speech dataset. This has been a really rewarding experience. Thank you.